Hello, welcome back to my channel FFBMD. Today's topic is drift of electrons and the origin of resistivity. Drift velocity. It is defined as the average velocity with which free electrons in a conductor get drifted in a direction opposite to the direction of the applied electric field. In a conductor, electrons are randomly moving in several directions. It means that the direction of electron is not fixed. Sometimes they moves in this direction, in another time it moves in this direction. So its direction and velocity is always changing because electrons collides with the ions and they change their velocity after collision. So it has random motion. Now expression for drift velocity. Let u1, u2, un be the random thermal velocities of n electrons in the conductor. Then the average velocities of electrons at a given time are given by u average equal to u1 plus u2 plus dash plus un divided by n equals to 0. These are the velocities of electrons at any time before the applied application of electric field. These velocities are before application of electric field. So electrons are moving randomly in all possible directions. Now consider the conductor is under the influence of electric field. Now electric field is applied along the conductor. Then force experienced by each electron is F vector equal to minus of E into E vector, because charge on negative sign for electronic negative charge, because electron has negative charge, and hence acceleration of each electron A vector equal to minus E by m, and so the every electron will start to drift. Here it is shown for one electron. For example, first electron is moving. If there were no electric field, then its direction will be this before collision. Here it is collision and changing its direction, making v1. But when we started electric field, when we switch on electric field, the electron again moving, but it has drifted in this direction. This part, this part shows the drift of electron, because electric field is in this direction, so electron experiences force in this direction, so the path of drift is in this direction, where m is the mass of electron at any time instant. Velocity of electron having thermal velocity u1 is v1, u1 plus a into t1, a vector t1. Similarly, v2 equal to e2 plus a vector into t2, v3 equal to u3 plus a into a vector into t3, dash vn vector equal to en vector plus a vector into tn. Now where t1, t2, tn are the time interval of collisions of electrons with ions respectively. These are the times interval of all electrons. For example, T1 is for first electron, similarly T2 for third electrons. This is the means that T1 time takes the electron to collide with the ion and change its velocity from u1 to v1. Now the average velocities of all electrons, that is drift velocity, Vd will be v1 plus v2 plus that is v1 by n. So we have Vd equals to now e1 plus a vector into t plus v2. Here it is to keep in mind that this v1 vector represent when the change in velocity, the velocity when electric field is switched on, and then the velocity has changed after collision. That velocity represents. So Vd, and this velocity will be called drift velocity. v1 plus v2 plus vn divided by n. So using Vd equal to, now v1 will be u1 plus a vector into t plus e2 vector plus a vector into t2 plus un vector plus a vector into Tn divided by n, or equals to un vector plus e2 vector plus un vector by n plus a vector into T1 plus T2 plus dash 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 Tn by n, or equals to u average. This represents u average plus, and a vector is given minus e vector by m into, and this is t average, so it is written t average. Hence Vd equal to 0 minus e vector by m into tau, because u average is 0. It was, that is before the average velocity of electron before the switch on of when electric field switch on was 0. Here we have calculated this value. This is the value of before the electric field applied on the conductor here, because this is moving randomly, so it has become 0. So using this value we have Vd equal to 0 minus e by m into tau, where tau is the t average, is the called relaxation time. T average is represented by tau and is called relaxation time. Now we have formula for Vd vector, that is drift velocity equal to minus e by m into tau. In magnitude form we can write Vd equal to e by m into tau. So this will represent the drift velocity of electrons. That is after applying electric field, all every electron is averagely moving with this velocity. It is it means that drifting with this velocity. Now average time between two collisions of all electron is known as relaxation time tau. It is also given as tau equal to lambda by Vrms, where lambda is the mean free path and Vrms root mean square velocity is given by under root 3 kt by m. From the kinetic theory we get this relation. So next, with rise in temperature due to increase in Vrms and decrease in lambda, relaxation time and hence drift velocity will decrease. Here it is from, because Vrms is directly proportional to T. With rise in temperature due to increase in Vrms and decrease in lambda, relaxation time and hence drift velocity will decrease. Next, dependence of resistance. Resistance of a conductor depends upon the nature of material and its dimensions. One, it is directly proportional to the length of conductor, that is R proportional to L, where R represents resistance and L represents the length of conductor. Second, it is inversely proportional to the area of conductor, area of cross section of conductor, area of cross section, that is R proportional to 1 by A, where A is the area of cross section. Hence R proportional to L by A, or equals to R proportional to rho into L by A. Where rho is a proportionality constant and known as where rho is known as a specific resistance or resistivity of the material. A specific resistance or resistivity of the material, it is a proportionality constant. Rho is constant for a given material, and rho is always constant for a given material. Now unit of rho, because we have R equals to rho into L by A, so hence rho equals to R into A by L. Now unit of resistance is ohm, and unit of area is meter square, and unit of length is meter, so ohm meter will be the unit of rho, that is resistivity or a specific resistance. Dimension, now we can calculate dimension, because dimension of rho equals to dimension of R into A by L. So dimension of R by RA, dimension of L, Now dimension of resistance is ML2T minus 3A minus 2, and dimension of area is L2, and dimension of length is L. So solving it, we get ML3 T to the power minus 3 and A minus 2. Don't, this is the dimension of current, not it does not represent area. Okay, here it is area, but here it is dimension. We have used same symbol for area and dimension, so don't be confused. This represent area and this represent dimension of current. Now definition of rho. It is defined as the resistance of an object in the form of unit cube made of that material. That is, it is defined as the resistance of an object in the form of unit cube made of that material. For example, if this is a cube and it has unit that is 1 meter in SI unit, if we take that is this length is 1 meter, this length is 1 meter, and this length is, that's a height, length and breadth all are of 1 meter. Then this cube, the resistance of this cube will be equal to the resistivity of material of this cube, so rho will be equal to R. And it is clear that it is keep in mind that resistivity is always the property of material. Next question, the resistivity of a metallic wire is 1 into 10 to the power minus 8 ohm meter. If the length of the metallic wire is doubled and its area of cross section is made half, what will be the new value of resistivity? Since for a given material rho is constant and hence it will remain same, 1 into 10 to the power 8 ohm meter, the resistivity of metallic wire is, if the length of the metallic wire is double and its area of cross section is made half, what will be the new value of resistivity? Since for a given material rho is constant and hence it will remain same, it is clear from the question. Now question, find the resistance of conductor along AB, along PQ and along RS. It is given in figure. Along AB means along this direction. This will be area of cross section for AB, and along PQ means in this direction, so this will be the area of cross section, this will be the area of cross section. And 3RS, in this case this will be the area of cross section, so we have to find the resistance. We know that R equals to rho R equals to rho into L by A, that is resistivity into length divided by area. So for RAB, this is AB, so for this length will be this, that is C, length of for this direction will be C, and area will be this area, this whole area or this whole area. So and this area will be calculated because it is this length is B and this length is A, so it will be AB, so rho into C by AB. Again RPQ, for this direction we have to calculate resistance, because rho always remains same but resistance can change. Here this direction, so length will be from here to here and this is equal to B, so B, rho into B, and area will be this area and this area will be A into C, so A into C. Again RRS means this length, this length is equal to A, so rho into A, and area will be equal to C into B, so we have calculated resistance. Next question. Find the resistivity of material if resistance is R equal to 100 ohm. Given this is a material whose length is L equal to 1 meter and the radius of cross section is given 0.1 millimeter. So what we have to formula R equal to rho into L by A. So rho and equals to R into you have R is equal to rho into L by A. So rho will be R into A by L. So R into now area will be pi R square because this area has pi R square and by L or and all value is given, that is 100 into pi 3.14 into the value of R is given 0.1 millimeter. So change it into meter. The 0.1 into 10 to the power minus 3 whole square and length is 1 meter, so 1, and solving it finally we get pi into 10 to the power minus 6 ohm meter answer. A uniform wire of resistance 100 ohm is melted and recast in a wire of double that of the original length. What would be the resistance of the wire? So here again material is same, so resistivity same, but resistance will change.